Dear friends, welcome back. Today we are going to connect an OLED display to the chip computer in order to monitor its CPU temperature in real time. Let's start. Hi guys, I am Nick and welcome to Educate TV, a channel that is all about do-it-yourself electronics projects with Arduino, Raspberry Pi, ESP8266 and other popular boards. Today's project is this. I have connected an I2C OLED display to the chip single board computer and I print the temperature of the CPU on it in real time. It is a very easy project to build and it can be easily ported to support the Raspberry Pi as well. Let's see how to build this project. I received the chip single board computer about a year ago. It is an impressive board. It costs $9 and it offers a 1 GHz CPU, 256 MB of RAM, Wi-Fi, Bluetooth and many more things. You can watch my review of the chip computer by clicking on the card here. As you can see, the chip computer is a lot smaller than the Raspberry Pi 3 board and of course it costs a lot less. 1 year later, the software developed for the chip computer is mature and we can easily build some projects with it. For this project we also use this small monochrome OLED display. It is one of my favorite displays because it is very easy to use since it uses the I2C interface which only needs to connect two wires. The cost of this display is around $6. You can find links for both parts in the description of the video. In order to connect the OLED display to the chip computer, we only have to connect 4 wires. The ground pin of the display goes to ground, VCC goes to the 3.3 volt output of the chip computer, SCL pin of the display goes to the SCK pin of the chip computer, and lastly the SDA pin of the display goes to the SDA pin of the chip computer. It is very nice to have the pins labeled on the chip computer, isn't it? It makes things so much easier. Maybe the Raspberry Pi needs to follow the same tactic with their boards. Now let's move on to the software side of the project. At first we have to install some libraries. First run these two commands in order to update the installed packages of the chip to their latest version. At last a GPIO library is ready for the chip so we can easily use the GPIO pins of the board from our code. It is the CH.I.P library. In order to install it, we follow the Python 2.7 steps that are provided on the library's GitHub page. You can find links for all the libraries in the description below. After the installation of the CH.I.P is complete, we have to install the Adafruit Python GPIO library. This library was developed for the Raspberry Pi, but it is now modified to support the chip as well. With this library, we can use libraries that are developed for the Raspberry Pi with the chip. Great! In order to install the library, we have to follow the instructions that can be found on the GitHub page of the library. After the installation is complete, we are almost ready. We only have to install a library for the display. We install a library developed for the Raspberry Pi from the user RM Hall. We follow the installation procedure as described on the page. We run these commands and then we manually download the library and we install it with this command. That's it, all the libraries are now installed and we can use the GPIO pins and the OLED display. I have developed a simple Python program that reads the temperature of the CPU and prints it on the display. The value on the display is updated every 5 seconds. I have named the program temperature_oled.py and I have placed it on the desktop. In order to run it at the console, we write the following two commands. cd desktop in order to navigate to the desktop and sudo python temperature_oled.py. That's it, the program will print the temperature in the console and it will display it on the display as well. The code reads the temperature of the CPU using this command. We read the output of the command and we print the temperature on the display. As you can see, the code is very simple, it is about 20 lines of code. As always, you can find the code of the project in a link in the description of the video. In order the program to be more useful, I added a cron job so the program to load automatically when the chip boots up. We run the following command, sudo cron tab -e, and we enter with the following line to the file. And we save the file. Now, if we boot up the chip, we can see that the temperature is displayed on the OLED screen automatically and it updates every 5 seconds. Now that the GPIO pins of the chip computer are easily accessible by software with the GPIO library, we can use the chip computer in our projects. As you can see, it is a great little board and the cost of it is very low, only $9. I think it is a great alternative to the Raspberry Pi. I would love to hear your opinion about this project. Do you want to build a similar project with the Raspberry Pi as well? Please post your comments below. Thanks! If this is your first time here, I would love to have you subscribed. In this channel, I post videos about do-it-yourself projects every Saturday. I love making things and I believe that anyone can make things. Anyone can become a maker. That's why I created this channel in order to share my knowledge with the community and learn from the community. I hope you will join us. Until next Saturday, watch, learn, build.